So now let us talk about C++ standard template library, or we call it C++ STL. What is this? The abstract data types we have studied and implemented, we have actually implemented by ourselves, but there is pre-implemented version or in C++, we call them standard template library, and this library consists of pre-implemented ADTs. And STL, this standard template library, they contain implementation of various algorithms which we use frequently. And you don't have to write everything from the scratch because we have this STL. The advantage of this standard library is that it saves us from a lot of coding and debugging, and because it was cautiously being built, verified, checked, so we can just use this STL and implement our other logic. This contents of STL can be categorized like this. We have containers. What these containers are? These are actually data structures, and the name is because they contain items. Containers are because they contain items. Data structures, what they does? Data structure contain data. That is why they are containers. And these containers can be further divided into sequence containers. These are data structure in which items are accessed by positions they are stored at, like arrays. We have already seen as an example in our previous session, list. Then we have associative containers. One was sequence container, then we have associative containers. In this, the items or the data members are accessed via identity or key. You use identity or key. The user does not know the index of an element that is sorted at, and they may not be in clear notion of an index for that, because they only know about the keys. This associative data structure or container we have already seen, like set and map. Then the division of one more container is adapters. These are quite restrictive interfaces that give us or give you specific functionality such as stack, queues, and priority queue. We are going to see priority queue later. And they are often implemented on top of other classes such as list. You have to use list or some underlying data structures to implement the stack, queues, and priority queue. Then comes the algorithm, that is they are pre-implemented algorithms. Like you can just include like the hash include algorithm, and this will include that algorithm inside your program. And these algorithms all live in your namespace std. These namespace, you can just think of a package or a folder, and this is standard. Std stands for standard, and they are roughly divided like this: search and compare, and they are iterator based, and they allow you to run some algorithm. That is, you can compare elements to a given one, count, add, all those things you can do. On what? On the elements of the container. And to employ these algorithm, you need to pass in an iterator of the container, because these algorithm work on this container only. And we'll see them later, but somewhat we'll see here also. Sequence modification, what they will do, they will affect the entire container, like filling arrays with some element like zeros and performing some computation on all elements. They are also iterator based. Then we have miscellaneous, like they contain mostly sorting algorithms and algorithm manipulation, like manipulating heaps, but they also have computing moments of our distribution and partitioning items. So let us see more on container classes. All container or containers implement at least these one of the following, like empty or size. Like operator is good, this is overloaded iterators, this are implemented. Size, what it does, this function size, doesn't tell you how many elements are in the container, but they how many elements it can hold, it will tell you, which is the capacity. And for all the container classes we are going to see just now, if you want to use them, you need to include this container name, hash include container name. Just as you included hash include algorithm, you have to have this hash include container name, which or where this container name is the name of the container you are going to use. You must either use this namespace std to precede this container name with something like std double colon. Also remember that except in your main file, this using namespace std is generally not a good idea, as it forces all program or every program that include your code to use this namespace. Sometimes it may clash with variable or class names. And as this name says, these classes are templated. What this means is, this means that you can easily build stack, queues and maps with any kinds of data stored in them. But we'll see them more in chapter 19, how you can build your own template classes, because once you know about this, you will be in a position to understand what this templated class means. So for now, let us use them. They are not so typical. When STL has declarations such as template, you have a class T. T is nothing but this data type. You can use any data type here. So that is why this is a template. You can use integer, float, whatever you want, T you want. Then you can have some class tag. In this, you have a template, class, some T data type, and then class T with some stack, and this stack is going to work on this T. And inside that you can have push T item. T can be the data type. So this is how a simple declaration of a STL can be. Like template class, you have key type, value type. This is a key value type. You have like a function called erase. You can erase a key type. This key type can be a type and this key. But you can define your own versions also, like stack string, string, map in bool, because this is the T here. And this T can be, that is why these are template. You can use your own data type. You can substitute any types here, including one you have defined yourself or other container types. For example, you have a map, each of those who use or whose values is a stack. A map whose values are stack. For this you can use, you can have like string S, you can initialize with hello world, and then my string stack dot push, because this is a stack you have defined. And what you are doing is you are trying to push this hello world, that is a string. You can push string. Also you can mind this because you have this map, you can erase some value. So in other words, C++ will automatically make sure that the right functions exist of the types you have specified. Then sequence containers, what are they? Sequence containers are similar to list. This is again a data type from class, in that they implement access to elements usually by index position. Sequence means by index position. They allow or they make you do reading, overwriting, inserting and removing. And most of them implement swapping, and several other functions are there. There are several sequence container classes with different trade-offs and implementation. This vector T, this is basically a list type. Vector is after all a list only, implemented using an expanding doubling array internally. Okay, this array T, this is implementing a fixed size array. It does not grow, does not provide insert or remove. It does. This interface and functionality is basically the similar as standard of array. It is available only starting with this C++ 11. So the main advantage over this version of new T 100 some value if you define, the advantage is that it catches array indices out of bounds and throws exception. This was not earlier, because you have to check for the exceptions for array going out of the bounds instead of leading to these errors, which is generally more prominent in the previous versions. And if list is there, this is a doubly linked list. This link is doubly linked list. It does not allow access by index. So in this C++11, this is a version, or this is a standard specification. There is also a singly linked list as forward list. It saves a bit of memory, but generally people use double linked list. The linked list contain some additional list specific operation like combining and splicing list. We also have DQT. This is not a queue in the sense that it combines a stack with a queue. It combines a stack with a queue. It is a data type similar to vector T. It is similar to vector T, but implemented with non-contiguous memory blocks, like non-contiguous memory block. Internally, it keeps a lookup table which has a multiple separate memory blocks to access when a specific index is requested. Because it does not need to copy all or copy over all elements when the size grows, inserting element is somewhat quicker. But some operations have more complex implementation and they may be a bit slower. So if you anticipate that you will be spending a lot of time growing your arrays, try using DQ instead of this vector T. Okay, this was STL, but we'll talk about STL in a later session. Thank you.